Alrighty, howdy. So I'll be talking a little bit about how we produce an MRI signal. So in order to produce an MRI signal, multiple steps need to occur in a precise sequence. Initially, there are tons of protons that spin in all directions. Then a magnetic field is applied, making the protons align with the poles. If these spins align with the magnet, they are then added together and create an NMV, or net magnetization vector. A radio frequency is then applied at 90 degrees to cause the NMV to move from the longitudinal to the transverse plane. The RF would then be turned off, resulting in the T2 decaying and T1 recovering, making the NMV move back. This would then result in a signal and a contrast since this each tissue has a different recovery time. I'll also describe a little bit on how MRI images are created. So we create an MRI image from the signal using the X, Y, and Z gradients, which have a different signal strength. A slice is selected along the Z-axis of the patient. The frequency encoding is conducted on segments of the slice along the X-axis, and the phase encoding is conducted on the Y-axis of the slice. The phase and frequency encoded data is then combined together to create the raw data, which is also known as the K-space data. This is then Fourier transformed to separate all components into their frequencies and amplitude values. Finally, software then takes these components and slots them into each space based on its frequency. The brightness is then adjusted using the amplitude of the waves. Thank you.